I spent a lot of time building robots. My hexapod took more than a year, just the leg for my robot dog took 200 hours, and some of my subscribers are still waiting for CNC Part 4. But I always wondered, can you build a robot in 24 hours? I told this to my girlfriend and her face said what the fuck, but I think I can build a super shitty robot in one day. Since it's 11 AM, I'm probably gonna have to skip school tomorrow, unless I just build a robot super quickly, but I'm gonna give it a shot. Also, fuck school. I opened up Fusion 360 and started CAD modeling. Since 3D printing takes a shit ton of time, I want to make the physical model of the robot first, and then I can worry about the electronics and the code. For the robot, I decided I'm gonna build a tripod, and I started by modeling a single leg. It's gonna have 3 degrees of freedom, which means 3 motors and 3 lengths, and I'm trying to model them as simple as possible. A tripod has only 3 legs, which means less stuff to print and less motors to power. This sounds great, but it also has a giant disadvantage. It's super unstable. Every time the robot wants to take a step, only 2 legs are gonna be touching the ground at the same time, and it's just gonna want to fall over. So I'm gonna have to either take super quick steps or maybe code the robot to move its center of mass around, something like that. I haven't decided yet, and that's a problem for future me. It's about 1 PM, which means that modeling this leg took me about an hour and a half. It looks pretty shit, yeah, whatever. I'm gonna start printing all these parts, and in the meantime I'm gonna model the body. Modeling the body was pretty straightforward. I started by creating a hexagon, then I extended 3 sides to add some space for the servo motors. I added holes for them, and in the end I just used a shell feature to hollow it out. Modeling the top part of the body was pretty similar. I again started with a hexagon, added some mounting holes, chamfers to make it look better, and in the end I added some clearance just so the legs don't smash into the body when they move sideways. It's about 3 PM, the leg has been printed. In the meantime I managed to model the whole robot. I think I'm going to start printing the second leg and assemble this one in the meantime. It's 3:30, I just tested the leg and it works fine, so while I'm waiting for the other 2 legs to finish printing, I'm going to solve inverse kinematics. Right now I can set the motor angles and the foot of the robot will move somewhere in 3D space. This is not actually useful because to make the robot take steps, I need kind of the opposite. I need to set the XYZ position of the foot and let the ESP calculate the motor angles, and this is called inverse kinematics. To solve it, you need to draw a bunch of triangles and solve a shit ton of equations, so if you're into that, I'm gonna post that on my second channel, and if you want the files for this robot, I'm gonna post that on my Patreon for free. At this point it was 4:30, and before testing the IK, I decided to make a transmitter first. So I got 2 ESP32 boards, one is gonna be the transmitter and the other one is gonna be a receiver / the robot. The transmitter is gonna read joystick values and send them to the receiver through ESP now. The ESP boards have wireless communication built into them, so we just need to get the address of the receiver and write some code. To get the address of the receiver ESP, I'm just gonna run this code. It's actually code from my robot dog project. Is this cheating? Probably, but I don't have much time and I didn't write this code anyway. So I'm going to select my ESP, upload the code. I can just press the reset button on my ESP, and then in the serial monitor I can read out the MAC address. It's 6:30 and I just finished making the transmitter for my robot. I just got the transmitter ESP and I added this joystick to it, so you can see it receives the values. If I press the switch, it switches from 0 to 1. If I move the joystick, you can see the values change too. With the transmitter finished, I started making the power circuit, which is gonna connect the battery's voltage and ground to the 9 servo motors. I did this by taking 2 rows of pin headers. I connected 1 row to ground, second row to voltage, And to carry out the PWM signal, which you need to set the angle of the servo motors, I just use a cable and connected each servo motor to a digital pin on the ESP32. As for turning the robot on and off, I just use a switch. So the battery's ground is always connected to the power circuit, but the voltage goes through the switch first, so it is connected only when the switch is on. If this sounds like too many cable connections and you actually like having your electronics in order, you should check out PCBWay, which is my sponsor. Let me show you just how easy it is to buy PCBs. Plug in your PCB dimensions, quantity and color. Click order and then you will actually see the manufacturing process in real time, just like these PCBs that are being made for my bipedal robot. Right now PCBWay is also running a design contest. Basically you want to create a CAD model of this bird character or any original character you want, then you send in the STL or step files and you can win $500. So maybe if you're a student or you're learning CAD, this is a great opportunity and you even got some nice motivation. The power circuit is finished, which is nice because I fucking hate soldering. This means I can start playing with this leg. I'm going to implement the inverse kinematics and connect these three servo motors to the power. It's 9:30. I implemented the equations and now I'm going to do the first test. So this is going to test the power circuit and also my code. Turns out I had the angles in radians, but I needed them in degrees. Fuck. I am 13 hours in, the lower body has been printed. I have spent the last 4 hours trying to fix the inverse kinematics. I think it works now. The issue ended up being this piece of shit of a joystick. It's got a drift of about 40%, which is just insanely bad. So when I was trying to move the leg left and right, it jumped much more than I expected and the leg went out of the workspace. Never mind, I think the inverse kinematics work, so I'm going to code the step trajectory. Alright, we got 1 AM, which means I am about 14 hours in. Yeah, I think I'm going to skip school tomorrow. Anyway, I coded the stepping trajectory and it works pretty well. To make the leg take steps, I wrote this Python code which generates me a bunch of points. At the bottom it's a straight line, at the top it's a cosine wave. Then I just copy these points into my Arduino code. The Arduino code basically tells the leg to move to one of these points. Then it waits maybe 10 milliseconds and moves to another point. And it does this over and over such that you get the stepping trajectory. So yeah, this leg is, well, it's not fully programmed because it steps only in one direction. And since the tripod has 3 legs offset by 120 degrees, I'm gonna need to be able to rotate the leg path by the tip of the point. So I still got some coding to do, but I'm coming very close to finishing this. 3 AM, holy shit. I made a decent amount of progress. I can turn on the leg and it's gonna start moving. And I can change the angle, so right now it's stepping in this plane. And with this joystick I can change the angle. After polishing the code, I had everything I needed and all that was left to do was to assemble the robot at 3 AM in the morning. This robot is much bigger than I expected. I'm just uploading the final version of the code. So what I did is with this joystick I can control the angle the leg path traces. That way I can control which way the robot walks. Then I took this path and I offset it by 120 degrees. Put it there. 120 degrees, put it there. And I also offset the cycle. So when this leg falls to the ground, this leg is gonna lift up and then that one, and the cycle is gonna repeat. And the cherry on top, although I have no fucking idea how I'm gonna close this. I'm actually surprised this doesn't even look bad. It's 5 AM, which means I'm about 17 hours in. Now I'm going to run the first walking test. Let's see how it goes. I mean, it could be better. Is it the best robot ever? Yes, this robot is super cool. Tomorrow I'm gonna film some nicer shots in the daylight, so you guys can actually see how the robot walks. And I'm gonna play with the code a little bit. Today marks the end of this challenge. This is what I was able to build in a single day, and I'm pretty happy with that. So the main problem with this robot is that it takes just a fraction of a second to tip over. That's why it wobbles so much and it doesn't walk well. What I decided to do is actually to tip the robot over. Not only does it look cooler, but it should be more stable because it's gonna have a larger moment of inertia. Taller things fall over slowly. Then what I can do even more is to derive inverse kinematics for the body. That way when it wants to take the step, for example if it wants to lift this leg, the body would move here and then it would be more stable. So that's a few things I can do to make this walk better. But the first thing I'm gonna do is just turn it over and see if that helps. It kind of works, but it's not really usable. I think you could make it a lot better if you added a fourth leg. Maybe if you played with the code, you could probably get this to work reasonably. I hope you like this challenge, it was really fun, and I think it's useful to show the whole process of building this robot. So thank you guys for watching, and I'll see you next time.